Okay, so remember what I said in the last video. I said if you had to review your raw score formula from chapter 3, do so because it was going to be necessary for the next examples that we're going to do. So before we look at example 7, let's review the raw score formula. And I actually have it up here in your procedure to find a data value or a raw score using the normal table. And I have your raw score formula right here. And we're going to do this step in this lecture. I'm going to show you guys how to use a z-score now to find a raw score. And we were doing this in chapter 3 to a certain degree. It's just we didn't have to find the z-score first. It was already given to you. So now we're just going to take this a step further. So let's just write down raw score formula. So remember, x is equal to the mean plus the z-score times the standard deviation. So it says a certain exam follows a normal distribution with a mean of 77 and a standard deviation of 8. A, what does a student need to score in order to be in the top 8% of the class? So just like I said a couple of lessons ago, whenever we're looking at a word problem, before you jump right into trying to answer the question, extract the important pieces of information. Ask yourself, all right, what's the population of interest? What's the variable that we're studying? What do I know about this variable? So in this case, we're looking at exams and we're interested in the score. So we're looking at exam scores. So X represents exam score. We're being told that exam scores follow a normal distribution. So score is normal, or X is normal. And there's a mean of 77 and a standard deviation of 8. So that's pretty much what we know about exam scores. Now let's go to the question. What does a student need to score in order to be in the top 8% of the class? So I'm flat out asking for a score, right? What score does a student need to get in order to be in the top 8% of the class? I'm not asking for a probability. I'm not asking for a percent. We're not looking for an area under the curve. I'm asking for a particular score now, but let's draw it out just like we've been doing. So sketch the normal curve because we know that score follows a normal distribution with a mean of 77. Now, where is this score going to go in order to be in the top 8% of the class? So the top 8% is good, right? If you take a test and you're in the top 8%, you're high up there. Your percentile rank is pretty high. So your score is going to be higher than average. So let's say this is the top 8%. That makes this area under the curve, right? If we write it as a decimal, convert 8%, that's 0.08. So I know that the area to the right of this particular score that we got is 8% because we're in the top 8%. So what is that score? So you see how I put X because X represents exam score and it's cutting off the top 8% from everything else. And I put a question mark. What is that score, right? Well, in order to get a raw score, because this X value represents a raw score, right? We need to use the raw score formula. What do we need for the raw score formula? We need mu, we need z, and we need sigma. I have mu and sigma, they're right here. But I don't know the z-score, right? What's the z-score that correlates to this X value, to this data value? If I had that, then I could plug into my raw score formula and get X. Well, you guys know how to do that. I just taught you that in the last lecture, right? So first, Let's get the z-score. So what's the z-score that separates the top 8% from the bottom 92%, right? 100% minus 8% is going to be 92%, which is 0.92. And remember, the reason I'm getting the area to the left is because when we use the calculator for inverse norm, we have to give the calculator the area to the left. So what's this z-score that separates the top 8% from the bottom 92%? So we could do inverse norm. So I'm going to go to my calculator. I'm going to do second and the vars key. I'm going to pull up inverse norm. And my area to the left is 0.92. And we're going for a z-score. So I'm going to leave the mean as 0 and the standard deviation of 1, because that's the mean and standard deviation of the z-scores. We should get a positive z-score, right? Because we're to the right of the mean. And to 2 decimal places, we get 1.41. So my z-score is equal to 1.41. Now I could plug into my raw score formula, right? My raw score formula, X, is equal to mu plus Z times sigma. And mu is 77. Plus now I know my z-score, which is 1.41. And I can multiply that by sigma, which is 8. So 77 plus 1.41 times 8. And we could plug that into the calculator. So 77 plus 1.41 times 8. And we get about 88.28. And we always want to round to the nearest whole number. So in this case, it's going to be about 88. So if we got an 88 on this exam, we'd be in the top 8%. That's the minimum score that we would need to be in the top 8%. Now I want to show you a shortcut. So the way we did it is by finding the z-score first, right? And then we changed the z-score to a raw score by using the raw score formula. We didn't need to do that step. Our calculator knows how to do that for us. We just have to tell it. So if you don't want to get the z-score first to have to convert it to a raw score, you can get the raw score immediately by using inverse norm, because we still have to work backwards, right? I know the area under the curve and I'm looking for a score, but now I want a raw score. So if we're going to look up a raw score in the calculator, we're still using inverse norm, but now let me show you. Let's pull up inverse norm. The area to the left is still going to be the same. I still have to put the area to the left, which is a 0.92. But now instead of putting the mean as 0 and the standard deviation as 1, I'm going to give the calculator the mean of the scores, which is a 77, and the standard deviation of the scores, which is an 8. The calculator knows that I want a raw score because I didn't tell it 0 and 1 for the mean and the standard deviation, which implies z-score. So if I give it the actual mean and standard deviation of the data set, the calculator knows that, and it's going to do what we just did by hand by plugging into the raw score formula. It's going to do it for us. And all it's going to give us is the answer. So we're going to get about an 88 again. We should get the raw score of an 88. And we did. We got an 88.24. When we did it the other way, we got an 88.28, and that was just due to rounding because I rounded the z-score before I plugged it into the formula. But again, to the nearest whole test score, we got an 88. So going forward, to get a raw score, I'm still going to use inverse norm, but I'm going to tell the calculator the mean and the standard deviation of the distribution, and I'm going to get it without having to plug it into the raw score formula. If you prefer to plug into the raw score formula, that's fine, whatever way you prefer. But going forward, I'm going to get the raw score immediately. So let's look at part B. What does a student need to score in order to be in the bottom? So we're looking for a score again, but now to be in the bottom 5% of the class. So let's sketch where our score would go if we were in the bottom 5%. So if you're in the bottom 5%, that's not great, right? That means you only did better than 5% of the people that took the test. So let's say this is the bottom 5%, and that makes this area 0.05, right, as a decimal. So what is this X value, this score that cuts off the bottom 5%? I know the area to the left, right? It's 0.05. So we could go ahead and do inverse norm because I want a score, particularly a raw score. So second, the Varus key, we'll pick inverse norm. The area to the left now is 0.05. The mean of the distribution is 77, and the standard deviation is 8. So the fact that I'm using the mean of the scores and the standard deviation of the scores, the calculator is going to give me the raw score. I don't have to use the raw score formula. And we get about a 63.84. And if we round that to the nearest test score, it's going to be about a 64. So X is equal to 64. So we would need to get a 64 in order to cut off the bottom 5% of the test scores. And now we'll look at part C. So part C says, what does a student need to score? So again, we're trying to find a raw score to be at the 40th percentile. So let's mark where the 40th percentile is. So the 50th percentile, or the mean, is in the middle, right? So the 40th percentile is going to be a little bit to the left of the mean. And the area to the left of that score is going to be 40%, or 0.4000. So we're looking for this raw score that cuts off the bottom 40% from the rest of the scores. So the area to the left is 0.4. And since we're looking for a score, we need to do inverse norm. So I'm going to pull up inverse norm. The area to the left of that score that we're trying to find is 0.4. The mean of the distribution is 77. The standard deviation is 8. And we get a score of about a 75, or 74.97. So we would need to get about a 75 to be at the 40th percentile. So this is how we find a raw score now under the normal distribution when we know the percentile rank, but now we're trying to find the data value. So there's two ways to go about this. You can either use the raw score formula by hand once you find the z-score, or you can make your life easier like I did on parts B and C, and we could use inverse norm, but make sure you put the mean and the standard deviation of the distribution, and the calculator will give you the X value. So in the next lesson, we'll do one more example, the last one in the worksheet, which is example 8.